Okay, we're back here, and we are again trying to find the minimum possible length of the giant slide. And what we just looked at is the minimum estimation for the distance between 4 and 6 seconds. And what we did in looking at 4 and 6 seconds, we chose the smaller of the two velocities, in this case 5.4, to represent our speed, because we're looking for the smallest speed to get our minimum approximation. So continuing on, now we need to look from 6 to 8 seconds. Oh, before I do that, that speed was 10, or that distance was 10.8 feet, multiplying 5.4 and 2. Now what we need to do is look between 6 to 8 seconds, and we can see that that's the smallest velocity. So, and pictorially, we're looking at this 6.6 and drawing our box, because we know that the area underneath that curve between velocity and time is distance. And so that is 6.6 meters or feet per second times 2, which is 13.2 feet. And we've looked from 6 to 8 seconds, and now we need to look between 8 and 10. So 7.4 is our minimum velocity. So we draw our representation, area underneath the curve, area underneath, again, area underneath a velocity time graph equals distance. And that area between 8 to 10 seconds has a velocity of 7.4. That's our minimum velocity in that region between 8 to 10 times 2, which is 14.4 seconds. Okay. So now that we have the minimum approximations for each 2-second interval, we can find the minimum length for the whole entire slide. So we're just going to add up each one of those minimum approximations. So from 0 to 2 seconds, the first one that we did right here, we had it was 4 feet, plus from 2 to 4 seconds, we had that it was 7.8 plus 10.8 plus 13.2 plus 14.4. And that, if we add up each of these areas, that's going to give us this total area of all these green rectangles. So adding those all up, we get that the total area for our minimum approximation, the minimum length that it could be, is 50.2. Now what we want to do is get a maximum possible length. And so basically we're going to do the same thing now and look at each of these 2-second intervals, but choose the maximum velocity. So I'm going to look at a different page here. In finding the maximum lengths, what we're going to need to do is, like I said, choose the maximum values. So from 2 to 4 seconds, now we're representing our answer in blue. From 2 to 4 seconds, I had a 5.4 velocity, or in other words, from 2 to 4 seconds, let's choose this value. So we have 5.4 times 2. I'm going 10.8 feet. And from 4 to 6 feet, well, let's choose the maximum velocity there. So we're looking at this. And so from 4 to 6, the maximum velocity is 6.6 multiplied by 2. And from 6 to 8 seconds, I'm choosing my maximum velocity, which is 7.4 times 2. So 14.8. Oh, noticing that I made an error in the last one. This should have been a 14.8. Going backwards, This should have been 14.8, which makes that 50.6. Okay, so always good to catch your work, and everyone makes mistakes. So now looking between 8 to 10 seconds, here my max velocity is 8, so drawing that with a blue, we have 8 times 2, which is 16. And same thing, these are my maximum approximations, and so to find out what those are, or to find out our maximum approximation, we're just going to add up each of these approximations, starting with the first one I found between 0 to 2 seconds, which was 7.8, and then add up each one of these values. So we're going to get 7.8 plus 10.8 plus 13.2 plus 14.8 plus 16. And when we do that arithmetic, we'll get our maximum approximation. So we find that our maximum approximation is 62.6. And again, that's the maximum approximation for the length of our slide. And then the last thing that we're talking about is, what is our estimation error or estimate error? Well, going back, we said that the minimum distance was 50.6 and the maximum distance was 62.6. So our estimate error is our maximum approximation minus our min approximation. So for this particular problem, our maximum was 62.6 and our minimum was 50.6. So our estimate error is the difference between those, which is 12. A key thing to notice when we're talking about the maximum and minimum approximations, and let me go back to this, is that the only difference between the minimum and the maximum approximation are one data point. In other words, if we look at the green, between 2 to 4 seconds, we approximated the distance to be 7.8. Well, in our blue approximation, that was our maximum distance between 0 and 2 seconds. We both have 7.8 there. And then between 4 to 6 seconds, my minimum approximated the distance to be 10.8. Well, 10.8 was the maximum approximation between 2 to 4 seconds. And then between 6 and 8 seconds, my minimum approximation was 13.2 feet. Well, that was my maximum approximation between 4 to 6 seconds. And then between 8 to 10 seconds, my minimum approximation was 14.8. Well, that was my maximum approximation between 6 to 8 seconds. So the only different values that we get are the last max value, which is 16. So let's get that in black to distinguish it's different. My maximum approximation had 16. That's the only value that my minimum approximation didn't have. And my minimum approximation had this 4 feet, which my maximum didn't. So in other words, in black, this black rectangle existed in my minimum. It didn't exist in my maximum. And then this black rectangle existed in my maximum, but not in my minimum. This is a tricky idea. It'll become clear in the next slide or two. So same sort of problem. We're again looking at time and velocity, only now the major difference is that I have more time. I have more time intervals. So the key here is that the greater data we have, the more accurate it's going to be. Or even more correct is that the less distance between each, the smaller the distance between each x increment. So the smaller these x values are, the smaller the distance between those x values are, the more accurate it's going to be. So if we wanted to find out the minimum possible distance, let's do this without graphing. So between 0 and 1 second, the minimum velocity, so we're going 1 second, the minimum velocity there is 2. And then between 1 and 2 seconds, the minimum velocity there is 3.1. And we're doing that for 1 second. So continuing on, between 2 to 3 seconds, the minimum velocity is 3.9 for 1 second. And then from 3 to 4, the minimum velocity is 4.7 for 1 second. Between 4 to 5, we're going 5.4 for 1 second. Between 5 and 6, we're going 6.1 for 1 second. Between 6 and 7, we're going 6.6 for 1 second. Between 7 and 8, we're going 7 for 1 second. Again, this is the minimum distance, the minimum possible distance, so I'm choosing the smallest velocities in those intervals. From 8 to 9, we're going 7.4 for 1 second, and from 9 to 10, we're going 7.7 for 1 second. Now, that's kind of spread out, and but the key thing here, and I'm not going to go through and add that up. The key thing here is let's compare this, and this is my minimum estimate. Let's compare that to my maximum estimate. So, and what I want you to see is that there's going to be a lot of repeats. So this was my minimum. In my maximum, let's go through it. So from 0 to 1 second, we're going 3.1 for 1 second. Notice that showed up there. And then from 1 to 2 seconds, I'm going 3.9 for 1 second. And notice that was here. And then from 2 to 3 seconds, I'm going 4.7 for 1 second. Again. And then from 3 to 4 seconds, I'm going 5.4 for 1 second. And we have that again. And then from 4 to 5, we're going 6.1. Again, choosing the bigger value because I'm looking for the maximum distance for 1 second. And we have that in our minimum. And then from 5 to 6, we're going 6.6 for 1 second. And then from 6 to 7, we're going 7 feet per second for 1 second. So that's going to be my 7 feet in that time interval. And we have that here. And then from 7 to 8 seconds, I'm going 7.4 feet per second for 1 second. And that showed up in my minimum. And then from 8 to 9, I'm going 7.7 feet per second for 1 second. And then lastly, from 9 to 10, I'm going 8 feet per second for 1 second. And that's the only value that doesn't show up in my minimum. So in other words, every single value in my maximum approximation shows up in my minimum approximation except for this one. And every single value shows up in my minimum approximation. Sorry, every minimum approximation value shows up in my maximum except for this value. So the only difference between the two, well, that'll be on the next video.